Hello, and welcome to this video tutorial. My name is Kyle. I'm currently a senior Information and Computer Technology major at East Carolina University. I've developed this tutorial as a part of my senior capstone project, and I hope that it enhances your understanding of Linux concepts. The server that hosts their respective websites. Bind uses a flat file database system to store this translation information. Let's take a further look at Bind. There are three types of Bind servers. The first is the master server. This server holds the original and master record for the zone in question. It can answer queries and will always have the right information. The second type of server is a slave server. This server houses a copy of the master database and can answer queries, though it is constantly checking the master for updates to the zone information. Finally, the last type of server is the hint server. This server does not store a local copy of the database file, but it does know who to query for the information. Now that you know the different types of bind operation, let's look at resource records. Bind stores translation information in several fashions. They are named resource records. On this slide, you'll find the most common resource records. Every database file will start with the SOA, or start of authority. This record establishes the server as the authority for the URL. It will also provide information on how slaves and hints interact with the database. The next resource record is the NS record, or the name server record. This record identifies which server is responsible for the domain. It is common to set a master name server and a slave name server as a backup. The next resource record is an A record. This record maps subdomains to an IP address, such as www.example.com to 192.168.2.5 and mail.example.com to 192.168.5.4. A records are the most common DNS records found on the internet. The next is CNAME records. CNAME records are also called aliases. They map subdomains to other subdomains. For example, say you want your users who need IMAP access to map to imap.example.com. You could create a CNAME record that points to imap.externalmail.com, which is your third-party mail provider. Finally, the last record is the MX record. It is also known as the Mail Exchanger record. These records tell mail clients how to deliver mail to the domain. So why do we use DNS? All DNS is a series of lookups. Your internet browser and operating system work together to do this automatically, though there are a few commands you can run in order to see what's really happening. First command is the host command. This will run a DNS lookup and return the zone information. You can look up IP addresses or by URL. What about if you know the IP address of the server and you want to see what domains it is hosting? Well, that's why reverse lookups were created. Reverse lookups have their own zone file associated with them. The name of the zone file would be the IP address of the server .in-addr.arpa. So a server with the IP address of 192.168.5.3 would have a reverse zone named 192.168.5.3.in-addr.arpa. This is where information about what domains this server is responsible would be housed. Now that you know a little about how Bind and DNS work, let's move on to the demonstration portion of this tutorial. First, we will install Bind. We must install both the Bind package and the caching name server package, as they are both required to run Bind. Next, we will ensure that Bind starts up on each reboot by typing checkconfig named on. Now let's look at the Bind configuration file, which is located in etc name.conf. Notice the directive listen on port 53 and the 127.0.0.1 after it. This tells Bind to listen on the local host on port 53 for queries. You would want to change this if you wanted this to be a public DNS server. Next, notice the directive var/named. This tells Bind where the flat file DNS records are stored. Now we will go to the bottom of the conf file and type the zone information for our new zone, example.rha. We will tell Bind that this server holds the master record, and finally, we will tell Bind what the name of the record is. Next, let's create the zone file. I've already placed an example zone file in the folder and named it example.rha.zone. All it has is the SOA and the NS record. Notice the serial number on the zone record. It is created by typing the year, month, and day, plus a change number from 0 to 99. Each time you change the zone record, you must change this serial number. Let's add an A record to this file. Make sure that you always add comments so that others know what you are doing. This record will point all users trying to access www.example.rha to 192.168.1.1. Then we will add a CNAME record that points users wanting to access the webmail client to mail.google.com. Now we save the file and exit Nano. Next, we will start the Bind server by issuing the command service named start. Now let's check to see if Bind is working. We will issue the command host-a and query example.rha. Make sure to set the local host directive afterwards to query this server. As you can see, Bind returns records for example.rha. Thank you for watching this tutorial. I hope you have a better understanding of how Bind and DNS work.